So in this question here, I'm going to integrate x over the square root of 9 minus x squared from 0 to 3. Now if I plug in 3 into this integral, I can see straight away that what's in our integrand doesn't exist. It's undefined for x equals 3. So if I just quickly sketch the graph of that, it will make a pattern something like that, and it'll have an asymptote at plus and minus 3. So that'll be a rough sketch of what it looks like. So this integral here is what's called an improper integral. So it's improper. So we need to come up with a strategy to make sure we don't end up with a result that is not the actual correct result. So in this case here, what we need to do is apply a limit. So now what we do is we set the limit as t approaches 3, and we change this parameter here to a t. That's how we get the t to be 3 in this integral. And what we could do now, we could just go ahead and integrate this and then keep applying the limit as we go along all the steps. So quickly to integrate this, so we set u equal 9 minus x squared, du would equal minus 2x dx, in which case dx equals du over minus 2x. And then we plug that in, and we don't need to do anything with our parameters because we're dealing with x's, and when x is 0 we've got 0 and t is just t on its own anyway. So let's just carry on. So limit as t approaches 3. So the integral is from 0 to t, and then doing our u substitution, let's go ahead with that. So what is x? We just leave it in there at the moment because we can see it's going to cancel out. So then we've got square root of 9 minus x squared, which is the square root of u. We have a du, and then we need to divide by minus 2x. So then let's just simplify this off a little more and get our x's cancelled out. So then we've got the limit as t approaches 3, 0 to t, x's cancel out, so then we've got 1 over, or minus 1 over 2 root u du. Okay, now if we integrate that, as this is minus a half, let's just do it over here. I've got u to the minus 1/2. Now if I integrate that, let's just do it here as a quick integral on the side. What I'm going to do is I'm going to add 1 to the power and then divide by the new power, which is a half. So then that would equal 2u to the half. So, and I've got minus 1/2 as a constant, so I'm just going to end up with negative square root of u. So then I've got the limit as t approaches 3, 0 to t, of 2u to the half divided by minus a half. So the answer to that would just be minus square root of u, which is 9 minus x squared. So getting back into our x variable as we need to do, as we've not changed our parameters, and that's from 0 to t. So if we evaluate that from 0 to t and then find the limit as t approaches 3. So we've got the limit as t approaches 3. So what happens when we've got a t? So we've got 9 minus t squared. So we've got minus square root of 9 minus t squared. And then when x is 0, plug in a 0 into there. So then we've got minus 9 minus 0 is just going to be 9. So we've got square root of 9. So minus the square root of 9. And then we could just tidy this up a little bit. That's just going to be 3. So then we've got the limit as t approaches 3 of, bring this to the front, I've got 3 minus square root of 9 minus t squared. Well, I can see here as t approaches 3, that will approach 0. So I've got 3 minus 0. So the answer to that is going to be 3. So then the result of this integral is 0 to 3. If I change that back to a 3 and get rid of this limit, that was our original question, this will equal 3. And that would be our answer to our improper integral. Okay.